Hello and welcome once again to this latest instalment in this series. This is still part of the final three. This is where I'm going through the last three questions on each GCSE exam since 2017. On my channel you'll find June 2017, all three papers already done. Did those a day or two ago. I'm going to be working on this today, so this is November 2017. This is paper one, the non-calculated paper. And we're going to start on question 21, and you can see this one I've already started before I started recording. So this is a third problem, and you can see we have an unrationalized denominator. So root 2 minus 1 unrationalized. We're going to start off by rationalizing that denominator, and you can see I've started that here by multiplying by root 2 plus 1 and then root 2 plus 1 again on the top. So root 2 plus 1 and root 2 plus 1 on the bottom. That's what I'm multiplying. So you can see that's going to give me quite a complex series of calculations to do. So you can see me just going through that here. So I've done 6 lots of root 2. That's 6 lots of root 2 here. 6 lots of 1. That's 6. And then minus root 8 times minus root 2. That's this bit here. Minus root 8 times minus root 2. And then minus root 8 times plus 1, that's minus root 8 here. Underneath, I'm going to have root 2 times root 2, that's just 2. And then the middle term will cancel out because you'll have minus root 2 plus root 2, that's going to cancel. And then you have minus 1 times plus 1, that's minus 1. So I have a rationalized denominator here underneath, perfectly fine. I end up with a couple of things I can notice on top. First of all, this here is root 16, so that's just 4. So you can see that happening here. So root 8 times root 2, root 16, that's 4. And then root 8, you might be familiar with, is root 2, 2 root 2. That's what root 8 is going to be. So I've got 6 root 2 minus 2 root 2. So minus 2 root 2, that's the 4 root 2. That's where that comes from. And then you've got the 6 here, and then minus the 4. So 6 minus 4 is plus 2, sorry. And so that's going to be 4 root 2 plus 2, very reasonably straightforward and worth 3 marks, so well worth you while going through that. I will just rewrite it in the order that the question requires, because the question up here is asking for something plus something root 2, so I'm just going to rewrite that just to get it in the form that the question wants, but to be honest, I didn't mark this right as well. Okay, I hope that's clear. Let's work our way through question 22. So question 22 is this one here. So this question is about similar triangles, and you can see it's talking about a diagram here, different sets of similar triangles. You've got ABE, so AB here, E here, and then ACE, the big one. And it's asking for 2 possible values of x. It says work out each of these values, state any assumptions you make in your working. So what you've got to do first of all is view this as 2 different types of triangles. So you've got the triangle where it could be ABE, so A here, B here, E there, or you could have the big triangle A here, C here, and D there. Now, if you're looking at these, we've got AB is 8, that's come from here, and this is 12 centimeters from the question. AD is going to be, well, 12 plus 3, so that's 15. And then you can also have AC, that's 8 plus x. Okay, so you've got that. Now, this is a simple similarity question, so you can see that the enlargement scale factor that takes you from 12 to 15 will be the same as the one that takes you from 8 to 8 plus x. So this is a simple enlargement question. What you're going to do is find the scale factor, so 15 divided by 12. This isn't the calculator exam, so you've got to do this without a calculator. So 15 divided by 12 is the scale factor that you need. So that's relatively straightforward. That's going to be, if you divide top and bottom by 3, it's going to be 5 over 4, so 1 1/4. What you're then going to do is you're going to multiply 8 lots of that 5 over 4. Is going to be equal to 8 plus x. So it's the same scale factor that takes you to there. So 8 times 5 over 4. Now 8 5s are 40. 40 over 4 is 10. So 10 is 8 plus x. And so x is going to be 2 in this scenario. Okay, so that's one of the possible values of x. Now the other possible value of x is generated by looking at the system slightly differently. So going back to my original diagrams, you can see I've assumed that this triangle is pulled out here, ABE, in that way, and then the other triangle, ACD. It could be that ACD, you view it the other way around. It could be that this triangle is turned around, effectively flipped over. So I'm going to draw that diagram again, but with down here so you can see it clearly. So here is ABE, so nothing different from ABE from earlier on. If you want to flip back in the video, you'll see that. So I'm writing down all the dimensions here, ABE, and then I'm going to flick this other one, the other triangle, I'm going to flick it upside down, or back to front in other words. So ACD, this time C and D on the other sides. So AC will be 8 plus x, and A to D is going to be 15. Now this time the scale factor is slightly differently worked out because the scale factor is going from 8 to 15. So it's a slightly different scale factor this time. So the scale factor will be 15 over 8. So my scale factor here is 15 over 8. Again, not massively easy to simplify. I think that's as simple as it gets without a calculator. But we're going to be multiplying that 15 over 8 by 12 then to get to my 8 plus x. So it's a very similar set of steps working than earlier, but just slightly more complex than earlier. And now 12 15s I can do without a calculator, or I have to work it out. So 12 15s, 5 2s are 10, 5 1s are 5, plus the 1 is 6, and then 1 2 is 2, and then 1 1 is 1, and then you're adding those up, you get 180. So this is 180 over 8, and that's 8 plus x. Lastly, I've got to subtract this 8, so I've got 180 over 8 minus 8 equals x. And again, I'm going to try and get this into a simple form for myself. So I'm going to do, to get it on the same denominator, I'm going to do 8 lots of 8, 64. So 180 minus 64 over 8. That's effectively what I'm doing here. That's going to be equal to x. And when you do that, you will get 116 over 8 is x. And again, you want to try and put that into as lowest terms as possible. So if you divide top and bottom by, in this case, 4, you will have 116 divided by 4 and 8 divided by 4. So 8 divided by 4 is 2, and 116 divided by 4, well, 4 goes into 11 twice, with 3 left over, and 4 goes into 36 9 times. So it's 29 over 2, or 14 over 5, 14.5 centimeters is equal to x. Okay, so again, it did talk a little bit about in the question about stating any assumptions you make in your working. So the assumptions that you're making here are just to assume that in one case the triangle is the right way up, and in the other case the triangle is the other way up, and that the scale factors are preserved across. Those sorts of things are the things that you're assuming. I don't think there's much more that you need to say. You've got the two values of x, 14.5, and you've got x is 2, and those are your considered values. The last question is obviously question 23. This is slightly more straightforward. As a last question, it's worth 5 marks. It's quite a lot of marks. It's talking about a triangle and a right angle triangle, and it's talking about the area of the rectangle being greater than the area of the triangle. Now the area of the rectangle is these two things multiplied together. The area of the triangle, half the base times the height. That's going to be quite easy to do. You can see that's going to be just x squared here. But we're going to do this one first. We're going to work out the area of the rectangle. So I'm going to multiply up these pairs of brackets, 3x minus 2 and an x minus 1. So I'm going to multiply that out. So I'm getting 3x squared minus 2x, and then minus 3x, and then positive 2 at the end. So it's going to be 3x squared minus 5x, and then positive 2 at the end. It's quite straightforward so far. The other one on the other side, the area of this triangle, half the base times the height. So the base times the height is 2x squared, and half the base times the height will be x squared. So the area of the triangle will be x squared. And it's telling you in the question that the area of the rectangle, 3x squared minus 5x plus 2, is more than the area of the triangle, so more than this. So you've got 2x squared minus 5x plus 2 being bigger than 0. You want to find with this particular inequality is bigger than 0. Now you can factorise this, I'm fairly sure. So you can factorise that very, very quickly. So it's 2x here and then x there. And you will see quite quickly how to factorise this. So it's going to be -2 and then -1 here. So that will give you the answers that you want, because of course you're going to have to work this through. And you want that where it's more than 0. So again, plotting this on the graph is quite useful. So again, we're constructing the roots here. X is a half, so half here, and x is 2. Yeah, x is 2, so that's over here. And again, you want those values where the graph is always going to be more than 0. So again, if you plot those values, it's going to look a little bit like this. Okay, so this value here, this is going to be +2. Okay, and then we're looking for the values where it's more than 0. So that's everything to the left of the half and everything to the right of the 2. So everything where x is less than a half, or everything to the right of 2. And that will be the range that fulfills that question. A lovely 5 marks to finish off. Okay, that was the final 3 for November 2017 paper 1. I look forward to seeing you soon for paper 2. If you're revising for your exams in summer, good luck. Speak to you soon.